So, today, I would like to go over and graphing a line. Let me remind you, the last couple of days we've been graphing with one variable, right? One variable, the graph is just a number line, one direction. Yes? Today, we're going to go back to two variables. Well, two variables, you're going to have an x direction and a y direction. It's not going to be a number line anymore. It's going to be a coordinate system, right? One variable is one direction, the number line. Today, two variables, you have to have two directions, back and forth and up and down, right? And within equals, we've graphed those before. We've graphed with equals before. I wrote the steps over here. Starting with step one. First you have to get it solved for y. How would I solve this for y?
Minus 2x.
Minus 2x. So I'm going to minus 2x minus 2x. And I get y equals 3 minus 2x. Do I have y by itself?
Yeah.
Mm-hmm.
So step one is done. Step two says, make a t-chart. That should be easy. Look. There's my t-chart. Anybody can't do that step? I don't think I can help you. Step three. Pick 3 x values. What can you pick for x?
0.
Whatever you want. You can pick anything you want. But remember, my graph paper looks like this. If you want to pick 100, you can, but it won't fit on my graph paper. So I would probably say values less than about 7 or 8 work good. What do you want to pick for x?
0.
I always like 0 because 0 usually ends up being easy to work with. What else?
2.
I like to usually pick a positive, like maybe 3, and a negative. What should we pick for our negative?
-1.
Negative 1? Easy enough. So step 3, pick 3 x's, I'm done. Step 3. Step 4. Probably going to be a little bit more work. Step 4 says, plug in each x value. You see that where the x is, we're going to put the value in. And we want to know what y value goes along with each one of those. So I'm going to put the x in. X is 0. And we're going to work it out and see what we get. What is negative 2 times 0? 3 take away 0 is 3. Next, I'm going to plug in my next x. X is 3. What do I get if I multiply that? What is 3 minus 6? Negative 3, yes. And last, I'm going to plug in x is negative 1. What do I get if I multiply negative 2 times negative 1? What is 3 plus 2? 5. So there we go. Step 4, I plugged in each one of the x values, and I got the y value that goes with it. Next step is to plot these points. 0, 3. 0 right or left and 3 up. And then I've got 3, negative 3. 1, 2, 3, 1, 2, 3. And then I have negative 1, 1, 2, 3, 4, 5. What's my last step?
Line.
Yeah, you got to connect those. And don't forget when you connect them, you got to put arrows at the end. Why do you put arrows at the end? Right, to show that it goes on forever and ever and ever. Can somebody tell me what is that? What does that mean? That purple line that we graphed, what is that?
That's a line. The line. That's why.
The slope. A line is made up of a bunch of points, right? How many points are on that line?
Infinite.
An infinite number of points. This line is made up of an infinite number of points. Would you agree that every single one of those points has an XY pair that goes with it?
Yeah.
And every single one of those XY pairs will work over here. It'll work in this equation. And by the way, if it works in that one, it's going to work in the original one as well. So what you have over there is a picture. It's a picture that represents every single XY pair that will work in that equation. Every single XY pair on the line will work over here. Those are the only XY pairs that work. There are no other XY pairs that will work in that equation except the ones on the line. Does that make sense?
Yes.
So you should know how to do this part already, right? We've done that before. And if you don't remember, we'll review it now. But today's lesson is actually not quite exactly the same. It is an inequality in there now. Instead of an equals, it's an inequality. But the good news is it's almost exactly the same. There's only a couple of other steps. So over here, the purple is how to graph a line. The red before and after are the additional things you need to do if it's an inequality. Starting with, you pretend it's an equals. So right here, we're going to pretend this is an equals. We just did that over here. You pretend it's an equals. You pretend it's an equals and you do everything else the same. You solve it for y, you pick your x's, you plug them in, you get the y's that go along with it. You plot each of these and you connect them. The only thing is, oh, I didn't write that over here. When you go to make your line, do you remember when we did just the number line? If it was just greater than or just less than, did we color it in? No. But if it was greater than or equal to, less than or equal to, I said those backwards, we colored it in. Well, the same is true for the line. If it's greater than or equal to, less than or equal to, we do a solid line. If it's less than or greater than, it's a dashed line. We have a greater than. So what does that mean? That means our line is going to be dashed. See how easy I make my line dashed? So I make a dashed line. You make a dashed line for this one because it's just a greater than. If it's got an equals with it, then you make it a solid line. The very last step over there, well, there's two steps, 7 and 8 kind of go together. You pick a point that's not on the line. I like to choose 0, 0. X is 0, Y is 0. And you take that point 0, 0, and you plug it in to your inequality. X is 0 and Y is 0. And you want to know, does that work? Is that a true statement? If you plug in 0, 0, does that work? Well, it's 0 plus 0, which is 0. Is 0 greater than 3?
No.
No. That tells me that point is not part of my solution. That point is not part of my solution. So if that point doesn't work, we're going to shade the opposite side. That means, well, hang on a minute, I'll tell you what that means. You can probably do a better job of coloring than I did, right?
Yeah. Probably not.
You don't like my coloring?
No, I probably can't.
You know what that means?
What?
That means any point that you pick from this side, any point that you pick anywhere in that region will work in this inequality. Would you knock it off? He needs to pay attention. So when I pick the point and it doesn't work, that means it's not part of the solution. So that means you're going to have to shade the opposite side. Does that make sense? The other thing that could happen, if you pick this point and it does work, then it means this point is part of my solution and I should shade that side. Does that make sense? Does that make sense? Do you have any questions? I think for this one, it's probably best if you practice. Do you have questions on this one? Yes.
So would you make like a little, like X and Y box thing?
I'm going to give you some. Just like this. Isn't that exciting? You don't sound so excited. Anybody with questions? So, here's the thing. The assignment is page 493. I don't like this marker. I don't like this marker. Page 493. Page 493. Don't move. For number 15. Ordinarily, when you go to pick your X's, you can pick anything you want. For number 15, I have a hint for you. If you pick 0, 3, and -3, your work will be a little bit less. You can pick whatever X you want. If you don't want to use my hint, you don't have to. But for number 15, if I were you, I would pick 0, 3, and -3. Hey Reese, would you pass this out for me, one per person?
Yes.
Please and thank you. Gracias.
I don't know Spanish.
Well, thank you very much.
AJ, not a